Okay, everybody, pause what you're doing for just a second. I will make this very, very brief. There's just one quick example I want to go through to end the week, and then I'm done. I'm done, and you can finish. I know how many people are going to test today or finish tests up. Okay, good. So I'll keep this really brief. Okay, so they want us to write this equation in vertex form and then find the vertex of the graph. So we know how to do this, right? We've done this in past chapters. Just knowing, we know vertex form is this, right? Y equal, you tell me, what's vertex form for a parabola? Okay, what goes out front? A times the quantity, x minus h squared plus k. There you go. Okay, and so we were able to do this by just remembering that h equals negative b over 2a, right? Calculating h, and then knowing that k is just f of h, right? That works, that's fine. There's another way to do this, though, that I want to show you. You can do this without having to memorize a formula. You can do this just by completing the square, because look what this is. This is, you see, when we write a quadratic function in vertex form, notice that I've got a square there, right? I've got an x minus h quantity squared. So all I've really got to do here is I've got to complete the square to create that perfect square, right? Okay, so how would I do that? Well, I'm going to do it much like, it's almost the same steps that we would have to solve an equation. I'm just going to, what I want to do is I want to get the x squared by itself on the working side of the equation, on the side where the x squared is located. So what would the steps be to isolate that x squared? What would I do first? And actually, let me rephrase that. I don't want to get the x squared by itself. I want to get x squared plus some number times x. Okay, just like we did when we were completing the square before. So I got to get rid of the constant, I guess, right? So what am I going to do first? Subtract 5. Okay, so first step is subtract 5. And that's going to give me y minus 5 equals negative 4x squared minus 7x. Okay, what else is wrong with this? If I want to complete the square, I need to just have a 1 in front of the x squared, right? So what's the other thing I need to do to get the right side set up to complete the square? I can't have that negative 4 in front of the x squared, so how would I undo multiplying by negative 4? Divide by negative 4. Okay, so I could divide each side then by negative 4. And I'm going to divide each term by negative 4, right? Because that's a common denominator. Okay, so what happens then? Now, on the left side, it looks like a mess. But that's okay. We're just essentially storing some numbers on the left side. And after we complete the square on the right side, we'll undo the steps we just did to get the y by itself again. Okay? But when I divide both sides by negative 4, that's going to give me, you guys agree, it gives me x squared. And then over here, I'm going to have negative 7x divided by negative 4 is going to give me a plus 7/4 x. Everybody agree with that? I'm just dividing each term by negative 4 and simplifying. Okay, now I'm set up to where I could complete the square on this side, right? So I'm going to rewrite this. I'm going to put a space in here on both sides for me to be able to add something to complete the square. So over here, I've got my y. I'm going to leave room to add something on that side. And then over here, I've got my x squared plus 7/4 x. Now I'm going to set up my template here. I'm going to have to add the right number to both sides so I can create a perfect square trinomial, right? Just like we did yesterday. And when I do that, I'm going to end up getting a perfect square here. Okay, what's the number that I'm going to have to add to both sides? What number could I add there to create a perfect squared trinomial? What's my recipe for that again? What do we do? Did this yesterday. Like, what if I gave you one like this? Like x squared plus 8x. What do I have to add there? Say it again. Well, 4 squared, right? Whatever the number is, b, whatever the number is in front of x, the coefficient of x, I'm going to cut that in half and square it, right? So I just would add 4 squared, right? I'm going to do the same thing here. Now, I assume the reason I'm getting just crickets in here right now is because that's a fraction, right? I'm going to do the same thing. This is b. I've got to take half of that. Well, what's half of 7/4? 7/8, right? So I'm just going to add to both sides then 7/8 squared, right? Now on this side over here, I left it as a 7/8 on the working side because what's the number that's going to get added to x inside the square? 7/8. And that way we can see that that number is reflected right there. That number and that number, the number that's being squared always ends up being the same as the number that shows up in the perfect square, okay? On the other side, though, we might as well turn this into a number. We just need to know what is that. Well, 7/8 squared is what? What does that simplify to? The fraction 7/8 squared is, what is that? How would I figure that out? What is that? 49 over 64. Yeah, I'm just going to square the top and square the bottom, right? Okay. So we get 49 64ths on this side, okay? And I guess I got to rewrite that whole thing, don't I? Gosh, I'll tell you what, all this stuff right here, just pretend it's right there also, okay? Now what? Now I've got to, I've completed the square on this side. And so what's the value of h, by the way? What's it going to be in my vertex form of my quadratic function? Right there's my template, right? What's h going to be? Negative 7/8, exactly. And we could have gotten that because negative b over 2a would have given me positive 7 over negative 8. Well, that's negative 7/8, right? That's what I was going to get anyway, but now I got it through completing the square. And then all I have to do now is isolate that y again so we can write this as a function. Okay, I'm just going to undo in the reverse order all the steps that I just took, which makes sense because that's what PEMDAS would tell me to do anyway if I do inverse operations. If I want to isolate that y, what's the first thing I would do on the left side to isolate the y? There's implied parentheses around that numerator, right? So what's the first thing I'd have to do, first step to get that y by itself? Don't be afraid to get it wrong. It's okay. But you won't, I bet. What do you think? I mean, I could. I'm going to have to eventually multiply by -4, but if I'm using inverse operations, I don't get to undo multiplication or division until after I do addition or subtraction. Is there anything I need to add or subtract to both sides? Ah, there you go. Good. I've got to subtract that, don't I? I've got to subtract that away from both sides. Everybody see that? So there's step one. I'm going to subtract. I'm going to run out of space here, aren't I? I'm going to subtract 49 64ths from both sides, and those guys cancel, right? So then what have I got? Let's rewrite this. So then I've got my y minus 5 all divided by -4 equals this, equals the quantity x plus 7/8 squared minus 49 64ths. Okay, now what's next? To get that y by itself. Okay, multiply by -4 to undo dividing by -4. Okay, good. So those guys cancel. Over here, that means I'm going to have to distribute a -4 all the way through because I'm multiplying the whole side by -4. Okay, what's that going to give me if I do that, if I distribute that -4? Now, sometimes people want to try to do something crazy like distribute that -4 inside the parentheses, but I'm not doing that. I've got a minus sign in the middle. I've only got two terms to distribute this to. So the -4 is going to get multiplied by the first term, and it's going to get multiplied by the second term, right? When I multiply it by the first term, I'm just getting -4 times the quantity x plus 7/8 squared. I can't distribute inside that because it's being squared, but I just distribute to that term. -4 times this fraction right here, well, negative times negative gives me positive. And you see I'm going to get a 4 times this fraction. That's the same thing as 4 over 1 times 49 over 64. I could reduce, everybody see that? I could reduce this fraction, 49 over 64 times 4 over 1. Well, look, I could rewrite this as 16. That's too light. I could rewrite this as 16, and that is 1, right? Because 4 over 64 is 1 over 16. Okay, so we're getting there. So then we've got y. What's left over here? All we had left was a y minus 5. And on this side, we've got a -4 times x plus 7/8 squared plus 49 over 16. What's my last step to get the y by itself? Did I do something wrong there? Question? Everybody okay with that so far? But I've got that 49 there, right? I've got 49 times 1 over 16 times 1, right? Because I multiplied the fraction 49 over 64 times 4 over 1. Everybody get that? Okay. Last step, I think we said it. To get the y by itself, add 5. There you go. So if we add 5, the 5's cancel. And all I have to do now is just combine those like terms, right? I have to get a common denominator for my 5. 5's over 1 right now, so what would I have to multiply 5 over 1 times to get a common denominator? I got a 16 in the bottom here. To add fractions, I have to have a common denominator, right? 16, there you go. I'm just going to multiply top and bottom by 16. And then finally, we're there. Now we've got our y by itself equals -4 times the quantity x plus 7/8 squared plus 49/16. 5 times 16 is 80, right? So I get 49/16 plus 80/16 is 129/16. And that's my answer. Okay, that was a pretty ugly one because we had all those fractions to battle the whole way. But you see that process. I mean, it's just all we're doing is, again, the only part I really care that you get out of this is when I'm trying to complete the square on the right side, I just need to get the -4 out of there and the 5 out of there so I have stuff I can work with to complete the square. I'm going to add just the right number to both sides to create the perfect square trinomial on the right. I know how that's going to factor. And from that point, I just have to reverse everything. Then I just have to algebraically isolate that y. And notice the steps I took were exactly the reverse. The first thing we did was we subtracted 49/64 from both sides. Well, how come? Because that's the last thing we did on the right side was add 49/64, right? Next thing I did was multiply by -4. How come? Because the previous step is where I divided both sides by -4, right? And then finally, my last step was I added 5 to both sides. How come? Because my first original step was to subtract 5 from both sides. So I just undid everything in reverse order then to get the y by itself. Okay, give me 1 to 5 on that. Okay. Which way would you choose to do? Probably the old way, right? It'd probably be easier just to do this, wouldn't it? But you need to know how to complete the square algebraically to do the same thing. Okay. All right. That was longer than I wanted it to be. I'm going to stop, shut up, and you guys can work, finish tests. If you're testing, please flip around.